Alright, in the next problem, we have a car traveling at a speed v, or some velocity v. Car has a velocity, initial velocity of something, well, car has some initial velocity we're given. And it's initially a distance, some distance from a barrier. So it's some distance d from a barrier. And what we want is, and the car slams on the brakes, and hits barrier sometime delta t later. And so we want to know, A, what was the car's constant deceleration before impact? Oh boy, that's going to be interesting. Constant deceleration before impact, and then B, how fast is the car traveling at impact? So velocity at impact, I'll just call that. All right. So for part A, now first of all, this is the sort of thing that will, frankly, drive most physicists nuts, because deceleration is not really something we like to talk about. We talk about acceleration, and if it's acceleration that's making you slow down, we just call that an acceleration in the direction opposite your velocity, or we just say you're slowing down, but we don't say constant deceleration. So this is really bad. What we really should be asking for is constant acceleration, and then expecting you to put a negative sign on it or something. But anyway, so the car has an initial speed v naught, and it goes 24. So the car starts here. So this is our little crappy car, and it goes 24 meters in 2.12 seconds. Well, sorry, it goes a distance d in a time delta t, and then hits with some final velocity, and then hits the barrier. So first thing we can do here is we can find out its average velocity by taking the distance it goes and dividing by the time it takes. So we can find v average equals the distance it's traveled divided by the time it took. And those are both given, so we can just plug those straight in. And then we can say that because this is constant acceleration, we can say v naught plus v final. It's v final and v impact are really the same thing. I probably should have just said v final, but you get the idea. So the average of v naught and v final is going to equal average velocity, and you can do this because we have this constant acceleration case. So we put these both together, and we can get that 1/2 v naught plus v final equals d over delta t. So now we take, what do we want to find? Well, we want to find v final, so we can just do that. We can say v final equals v. Let's see. Let's say v final is going to equal. So I'm going to multiply, say, both sides by 2. So 2 over 2 equals 2. So v final equals 2d over delta t minus v naught. And so this here, if you can get past that little scratched out bit, that is our answer for part B. And then for part A, you know that the average acceleration is going to be delta v over delta t equals, and that's going to be delta v is final velocity minus initial velocity, and we already know delta t, and we know final velocity. Actually, well, I was using naught for initial, so actually this is kind of already bad for me, but this is going to equal v final would be 2d over delta t minus v naught minus v naught again. So this thing in here is just coming down from the equation above. It's coming down from this part, and then we also have the extra minus v naught all over delta t. And so then we can take this over and say average acceleration is, let's see, so 2d naught over delta t divided by delta t equals 2d divided by delta t squared. Is that right? Yeah, it is. Okay. And then this is going to be minus v naught minus 2 v naught over delta t. That supposedly is going to be our average acceleration. Okay, let me pause this while I plug all these numbers in. Remember, this problem gives you initial velocity in kilometers per hour, and you want to convert it to meters per second. So that's something you got to watch out for. So let me pause this for a second while I try to plug this in and see if I got it right. Okay, so this was correct as it turns out. And these are the answers I got. This was my, let's see, this number here was the final velocity I got for my initial velocity. My initial velocity is 56 kilometers an hour, which comes out to 15.56 meters per second. And then my time was this here, 2.12 seconds. And so I got this answer for a final velocity, which turns out was correct. And then average acceleration was change in velocity divided by change in time. And it turned out I calculated change in velocity, delta v over here, negative 8.48 meters per second. Conveniently, when I divided that by my time, I got exactly negative 4.00 meters per second, not meters per second squared, sorry. And I don't know if that's they set that up to work that way or not, but it's kind of convenient. So I'm happy it worked, and on to the next problem.